on Kiwi.
Live from the New Scientist Labs, it's Janine Young with Wammo on Kiwi.
Let's talk new science from the New Scientist Laboratories, Melbourne City this morning. Janine Young, good morning.
Good morning, Wammo.
First story this morning. It sounds like such a good idea, doesn't it? A bunch of scientists get together and decide, let's recreate the sun here on Earth. Sounds real good, eh?
Because absolutely nothing can go wrong.
Exactly. Sounds like the Hadron Collider. Yeah, let's clash some particles together. Sounds like that'll be fun.
Well, that one actually, despite all the things that went wrong and they're now rebuilding it,
yeah.
there was talk of potentially creating a black hole that was going to destroy the universe.
That's right.
Mercifully, that didn't come to pass.
Yeah.
I think the chances of this one going slightly wrong could be a little bit higher because there's a place in France near the Côte d'Azur. There we go.
Ooh, well done.
The sun, yes. I think they're going with some marvellous irony there. Is a place called the International Thermonuclear Experimental Reactor. Catchy, ITER. What they're trying to do is take hydrogen variants, deuterium and tritium, for anybody who cares, and bang them together and make them produce energy. Now, that's the same reaction that's happening in the sun. And you think, well, if it happens in the sun, how hard can it be? The answer is quite, because they've got positive charges on them, these molecules, and they don't like being pushed together. Like positive magnets, they repel one another. So it takes a huge amount of energy.
So it's kind of like splitting the atom. And they don't really want to split, but we'll make them do it.
We can if we try hard enough.
Yeah.
This ITER reactor that they're building at the moment, and it should be completed in 2018.
So that's when the world ends, everyone, 2018. Good? Mark that in your diaries.
Yes, you've got 9 years. They're actually going to push them together at huge temperatures. They're talking at 15 million Kelvin. Now, Celsius is only 240 degrees different. So let's just say it's degrees, because it's close enough. 15 million degrees in the sun, and it barely bubbles along. It's going, but the supply there has lasted for billions of years. They're talking about racking this reactor up to 150 million Kelvin. Now, that's bloody hot.
But surely there's nothing... there'd be nothing on Earth that can contain that heat. Surely there's nothing that can... Because everything around it would melt. Yes,
you would think. This is a huge engineering challenge. And what they've been able to try and work out is how they will contain it. They're actually going to be using a ring of... the plasma will be contained in a ring of magnets, like a magnetic field. It's the kind of thing that you see in sci-fi movies. It's always angels and demons. I think the dangerous thing in the middle that I can't remember what it was meant to be contained by a magnetic field. They're talking about doing the same thing here.
I will forget that you just quoted Angels and Demons here on the show.
I started reading it as a crappy plain book, and I must confess it's still sitting here, and I still haven't finished it, because it's just shockingly written.
Yeah,
I've never seen a book so overwritten in my... Anyway, moving back to this. Outside the magnetic cage, they're going to put a vacuum around it. So that's one way of being able to contain the plasma. But
right.
It's not as simple as that either, because then you've actually got the process of trying to make this thing run. They're going to hit the plasma cooked in 3 different ways. Secret herbs and spices.
Yeah.
They're forcing a current through the plasma. It's going to be blasted with microwaves and bombarded by high-energy atoms from particle accelerators. So you can see how much it's going to take to make this thing burn, for want of a better word. The cage is called a tokamak. It's a great name, but they're basically saying that this needs to be shielded in so many ways. They need to have walls that are basically 1/4 of a metre thick. It's seriously thick.
Yeah.
And then you've got to have special linings on it because you've got neutrons escaping, which are going to be able to strip any of the atomic structures of most of the things that are available. So they're using a special type of steel. Ironically, the same kind as they use in cutlery.
Oh, really?
Yes, because it's actually very stable and it can stand having a whole bunch of atoms knocked out of its structure.
And then you've got to have a cackling sort of scientist kind of laugh, evil type laugh, and some kind of laser attached to it.
A laser. Yes, I would hope there's no cackling scientists here because they're engineers. And engineers, I would hope, don't cackle.
Good, right.
Yes, they're engineers. There's a big difference there.
Okay, sure.
They have to contain heat. They have to contain the neutrons and the like that come off. There's a bunch of things that need to be contained with this, and it's kind of complicated.
Okay, so are there some possible positive spin-offs for this?
The whole point behind doing this is that even though it's going to take a huge amount of effort to make the thing run, contain whatever comes out of it, it will produce more energy out than goes in.
Right.
10 times more energy. What they're trying to do effectively is get the heat out of it, which will then be taken away by water, which can then drive turbines, and you'll see that it's basically a massive steam generation machine, if you like. But it's the massive amounts of energy that will be released once you get this thing running.
So is this a possible alternative to nuclear energy?
Yes.
But no doubt there'll be some kind of byproduct from it.
But there won't be as much as there is with fission.
Okay.
This is talking about fusion, so you're pushing things together. Fission, as you were saying before, is ripping things apart.
Gosh, we're learning stuff here.
Oh, that's why I'm here.
Yeah.
I do what I can. But in this case, no, there won't be as many byproducts. The plasma will generate a particular type of helium that can contaminate the plasma, but they've got a plan for a base across the bottom that will actually get rid of most of that. But they're saying that a lot of the emissions from this, the leftovers, the radiation, if you like, that's equivalent in a fission reactor, won't be anywhere near as bad for a fusion reactor if they can get the thing to work and if they can contain everything.
Okay, well, finally, let's finish on the story about trying to detect liars by getting them to draw.
Something that's much more down to earth and we can actually keep our heads around, because that other one is all a bit much and a bit confusing, really. There's a whole bunch of researchers at the University of Portsmouth in the UK that have been wondering how you can detect liars, because obviously you can tell a story, and there's times people can't tell if you're really good whether or not you're lying. So what they asked a whole bunch of volunteers to do was to go on a bit of a magical journey. They had to, a conspiracy type thing, they had to go to an agent and pick up a computer and hand it to another one, and then they were asked to draw the scene.
A magical journey? If a doctor ever came up to me and said, let's take you on a magical journey, I think that sounds like a good drug trial.
That's probably me just being a little bit excited
okay.
about it, but they were asked to go on a cloak and dagger mission. Is that better?
Sure. Yeah.
It's all agents and spies and that kind of thing.
Yeah.
But they asked them to sketch the location of where they had received the laptop, and they found that the ones who were lying about how they received it didn't include a first-person transfer of the laptop, whereas the ones who actually drawing this as they had seen it because they were really there, drew it from a completely different perspective. That was like a bird's eye view for those who are lying. So it seems that the idea that they have in their head, they're not connecting kind of spatially, or they're not actually putting themselves in that situation because they're over the top imagining it.
Okay.
So it means that there's a couple of, although they also didn't include the one of the two agents that was involved, the second person that they spoke to, they didn't include that person, whereas those who were actually there did. And it's always easier to recall something that actually happened than something you're making up. And that's why I gave up lying years ago, because it's just too hard to keep track of everything.
Racked with guilt.
Oh, it's just keeping track of the story. That's what I found to be the difficult thing.
Yeah. Did you do a bit of lying in your past, did you?
Yeah, I went through a stage where I thought, no, it's much more exciting to make stuff up. But, it's just too much like hard work.
Nice one. Hey, Janine, thanks for those two stories. Fascinating stuff this week, and we look forward to chatting with you again same time next week.
Okay, talk to you later.
And those stories you'll find in New Scientist magazine coming out next week.